Hello and welcome to today's video, which is one of the most important videos in the course, and that's the introduction to sets. A set is a collection of unordered, distinct objects that we call elements. And there's really three key things here. The first is that they're unordered. We'll talk about what that really means in a second. They're distinct, so they're unique. So each number or each word in the set is not like the others. And they also can be numbers or they can be something else. So that's important as well. They can be numbers, they can be words, they can actually be sets inside of the set. There's all kinds of different things that we can have inside of sets. And there's a lot of different ways that we can represent sets in mathematics. There's one way that's good for visual learners. We'll go through that right now. That's where you kind of consider it as a box. So you have this set, we'll call it set A, and it could be a box with, how about the number 5, the number 2, and the word car. So this is just to show you that there can be words and numbers inside of a set, and that's okay. And we labeled this set A, so that's another way we could write it. We could say this is set A. We'll talk about that in a second. And then there's kind of the most mathematical way. This is the way you're going to see in this course most often. So you put a little curly brace, you write all the elements out, so 5, 2, and car, and then you put another curly brace there, and you just separate them by commas. So that's another way to write the set, and that's fine too, and that's how we normally do it. So curly braces, each element separated by commas, and then also we could just say set A. So if we define set A to be the set that contains 5, 2, and car, I can just write in a problem the set A minus the set B, or set A, what's the power set of A? That could be a question, and you'd have to know, okay, well A is the set 5, 2, and car, and you can visualize it either way. So that's just the introduction here, and those are some of the ways that we can represent the set. Now let's get into these important points. So remember that I highlighted the three words. I said unordered, distinct, and anything can be inside of them. Well, now let's talk about that more. So first, there's no order in a set. They're unordered, which means the set 0, 1, 5 is the exact same thing as the set 1, 5, 0. And the best way to think about that is to think about it using the visual representation, where we have the box, right? We had the box, and we'll say we had 1, 5, 0. But now if I have 1 or 0, 1, 5, notice that these are the exact same thing. It doesn't matter where it is inside of the box. It just matters that in my box I have a 0, I have a 1, and I have a 5. That's all the set is saying. So there's no order in a set. We got that. The second, the repeated elements are only listed once. That was when we highlighted the distinct word. So you're never going to see in a set two of the same element. You're never going to see 0, 0 or 1, 1, so on and so forth. You're only going to have it listed one time. So the set containing 0, 0, 0, 1, 5, 5, we would just write as 0, 1, 5. We don't say how many objects there are. That's really important and something you got to know. And also, sets can be finite or infinite. Remember, finite just means it's countable. So that's something like 0, 1, 5. It's obviously finite. There's only 3 numbers. But they can also be infinite. So look at this set Z. This is infinite because we have those dotted lines. That implies a repeated pattern. And what is this pattern? Well, we're going from -2, -1, 0, 1, 2. It's going to go all the way up to like 3, 4, 5, 6. And on the negative side, it's going to do the same thing. -3, -4, -5, so on and so forth. Well, these are actually the integers, aren't they? All the integers, negatives and the positives, and they include 0. And that's an important set that we're going to talk about later, and we usually represent it in mathematics by Z. So that's an important one we'll get into. Okay, so here, the important sets. First, the natural numbers. This is a set of positive integers. Some teachers like to say the natural numbers include 0. They like to say the set of natural numbers is 0, 1, 2, 3. But the vast majority are doing what we do here, which is the 1, 2, 3, 4. And I like to think of natural numbers as counting numbers. That's what I like to say to myself because it just makes it a little easier. So counting numbers is the same thing as natural numbers, notated by the set n. And counting numbers make sense that it's 1, 2, 3, 4, 5, because when you learn to count to 10, you don't usually say 0. You start at 1. You say 1, 2, 3, 4, 5, 6, so on and so forth. So I like to say them as counting numbers. And that's represented by the letter n, so that's important because in problems, especially in discrete math, they're going to say set n, and they might say, what's the cardinality of set n or something like that, or is set n a subset of this set? So you need to know what n means, and that is the set 1, 2, 3, 4, and all the way to infinity. Then also the set of integers, we looked at that one, includes all positive and negative integers. I didn't know another word to do that. It's really just all positive and negative, like numbers, whole numbers. So all the way from negative infinity, counting by 1 all the way to 0, and then all the way to positive infinity. And then we have the rational numbers. So I'm sure you guys know this already. Those are any number that you can write as a fraction. So rational numbers include things like 5/2, how about 4/3, anything like this. 3 seconds, and they also include the whole numbers like 2, like 1, like 0. So it's a lot more extensive than the integers. But the problem that we have right now is that we don't have a good way to write this as a set. So let's do our best, and then in the later video we're going to have set notation that will really help us write this out. And usually the rationals are notated by a q. So we'll say q equals, and now we want to somehow figure out how to write the rationals. And I know that it's going to repeat all the way from negative infinity to infinity. Well, how about we start with just saying, see, the thing is we really don't have a good way, so we're just going to kind of have to guess. How about -3/2? Then we could have -2/1, -1/2, and so on and so forth. We just have to show some pattern, just showing that it has all fractions. There's not a good way to do it, and that's the problem we have right now. This is wrong. There's no way to show it with just doing a repeating pattern. So what we need is some variables, and we'll get into how to write this set later on. But just know the rational numbers, notated by q, includes any number you can write as a fraction, and we'll learn the set notation in a few videos. Alright, so now elements and cardinality. This is kind of the last thing I want to touch on in this video. It is very important, so hopefully you're still awake. And the symbol for inclusion is epsilon. So when I want to say, let me show you here. So let's say I have set A equals, I think we've been doing 0, 1, 5. So you'll often see this in discrete mathematics. You'll say 0 is an element of A. And that's that epsilon right here. That's the inclusion. So I said 0 is an element of A. Well, what if I want to show exclusion? Well, how about 7? That's not an element of A, so I just put the epsilon and I do a dash through it. 7 is not an element of A. So that's that simple. And the way we do it is we just say, well, 0 is obviously inside the set and 7 is nowhere to be found. So that's how we know that it's an element. And we'll get into some more specifics of how to really tell if it's an element, because this will get more complicated later on. And then cardinality, the size of the set. It's really the number of elements that you have. And it's notated by straight lines on both sides, and you might be saying, well, that's how I notate absolute value. And you're correct, it looks the exact same. So it's absolute value of B. Well, you wouldn't want to say absolute value, you'd want to say cardinality of B is going to be the number of elements in B equals number of elements in B. And looking at set B that we have here, the B equals the square, rectangle, pentagon. Obviously there's three elements, right? So the cardinality of this set is 3. And if I wanted to show inclusion, I could say square is an element of B, and 5 is not an element of B. So the cardinality is the key thing for here, and that's just saying the number of elements. Well, I count 3, 1, 2, 3, so that's the cardinality. So this was just a simple introduction to sets. I hope you kind of understand the basics. The keys are these underlined words, that sets are a collection of unordered, distinct objects that can be numbers or something else. And we'll get into set notation, which will help us write the rational numbers set that we touched on. And we'll also do a lot more practice with cardinality, because that's something that can also be a lot more advanced than what we just touched on today. So thanks for watching, and I hope you enjoy the next few videos. Have a good one.